Okay, so I brought some stuff back from the tool room. This is the one this is our favorite one.
Yep.
Yeah. So this one goes to 600 inch-pounds, and that maxes out. And it's got a little indicator that'll tell you when you. Whatever. All right, and then the click type. Like I said, I like the click type. So this one goes. Let's see. Was it set correctly? No. Where should you leave it?
The lowest setting.
All right. And then was this set at the lowest setting? No. 200 is the lowest setting.
That's what it was set at?
No, it was set at like 350. Want me to pass them around?
Yeah.
You guys are.
Make sure we don't drop it.
Or abuse it.
What would be called abuse?
You have to ask.
Yeah.
Fix it out. Fix it out.
Don't touch it.
Okay. So like I said, as much as you can help it, don't start and stop. But obviously you have to torque properly. You don't like a wheel half or propeller where there's 6, 8, 2, 4 bolts. Space it out so a little bit, and then final. And that is starting and stopping. And you just have to, because that's better than not. Okay. Use the correct torque chart. Use the correct torque chart. All right, what is the correct torque chart? AC 4313, right?
Nope.
Why not?
Because it's acceptable.
That's right. That's your last. It is the huh? Yeah, it only shows dry too. So, for example, first of all, manufacturers specific torque prevails. In other words, the manufacturer's specific torque is the first thing. So if I look at this torque chart here in this manual, and I go, let me see if I can find something, and let me see here. That'll be here somewhere. Keep going. Fast forward. There we go. All right. We'll just take the first one. It says a connecting rod nut, 3/8 24. Let's just take a look at this. Three-eighths 24. One more. There we go. What should 3/8 24 be torqued to? Well, it's 3/8 24. Is that coarse or fine? Fine thread. There we go. I gotta get rid of that, so I get rid of this. Jeez. One job. 3/8 24. What is my recommended torque?
160 to 190.
And the most I can go is
390.
390. Well, according to this, these connecting rod nuts that are 3/8 24 should be torqued to 480 inch-pounds. That does not match this, does it? So if I would have said 3/8 24 and used 4313, I would have been here. And you know what happens when you don't torque a connecting rod nut all the way? They come apart, and then the engine has what we refer to as a dynamic disassembly. They blow up in flight. It is that's just the way that works. And so, first of all, it's the specific torque. And by specific torque, I mean I'm looking it up. I'm saying that specific nut that goes on that specific thing is right there, and it says 380 inch-pounds. By the way, see, it's not, so that's for certain engines, it's 480. For other ones, the 3/8 24 is 360. This one is tightened to this length. So there's 3 different options there. I'm just giving you one. So, okay, so specific torque. Then, after the manufacturer's specific torque, oh, and by the way, This is wet torque with 100 weight oil and 15% STP, which is somewhere in the front of the book where it tells you to do that, if I'm not mistaken. Some things they want 25% STP and some things are 15. It's really weird. Okay, then they have manufacturer's general torque. So where's my general torque here? There we go. 3/8. So this is just general. Bolts, screws, and nuts. In other words, if they didn't mention it specifically before and you look the whole thing, it's nowhere. Then you can go to the general and go, oh, 3/8 stuff. Well, they want it 360 to 396 inch-pounds. So it's just a general. So it wasn't specific. So it's manufacturer's specific torque first, then manufacturer's then manufacturer general torque. Then, if there's no other information anywhere else, and not likely to find this, because we could take even this Lycoming. Well, if it's not specific, then it's general. It covers 100% of the engine right there. There's no ambiguity. You're working on an airframe, working on the Cessna. Well, I want to know what the torque is for the bolts that hold on the nose strut. And so I read all of that. And by the way, sometimes it's terrible. The torque can actually be written in the instructions. It's not a chart. You have to read the whole thing. It says, and then torque too. And why would you put it there? You got to put it in the table, but they don't. So you have to read the whole thing. Read the instructions. And they say, and torque to spec. You're like, well, where's the spec? You got to find the spec. Or maybe it doesn't tell you at all what that bolt was. Then I'm going to go to the Cessna's going to have a table just like that. It's going to look a lot like 4313 and give me the torques there. So then I'll go to that. But if I'm working on a Cessna 140 or some very old airplane built back in the 40s, it may not say anything. I mean, it'll have some specifics and that's it. And so you're putting the wing back on. You're like, there's no torque for the wing bolt. I'm making that maybe, but maybe it may not be. Is there, Harry? No, you not put the wings on yet.
Yeah.
So there's no torque for the wing bolt. Well, I kind of feel like I want to torque the wing bolts. To me, that's sort of important. So where am I going to go at that point? There's nothing in the manual that's specific. There's not even a general table in there. I was like, well, come on. Cessna, what am I going to do? Then where am I going to go? Okay, then AC 43. So it's the last. So if no other value, then use AC 4313 1B.
But isn't the AC 43 1B specific to thread type?
It is. They're specifically oil-free CAD-plated threads.
So if it wasn't CAD plated, you couldn't use it?
You really couldn't. You really couldn't. So if necessary, yes.
What do you do for stainless steel? Non-CAD, just straight stainless steel.
You better hope the manufacturer gives you something. Then I'm going to use 4313 as a guide. If I got nothing, that's what I'm going to do.
So how far off would it actually be?
Not very. Could be a little bit. 10%, I'm guessing. I don't know. If necessary, add friction torque. To final torque, to final. In other words, you have a rather large high temp, not so high temp nut, and well, it's pretty tight going on there. Using a kind of a big wrench there, and it's taken 20 some inch pounds just to move this thing, and it hasn't even touched anything. Well, you have to add that 20 inch pounds or whatever you're twisting it to your final torque. That adds. Hopefully that made sense. Now, if you've cross-threaded it and it's just really hard to turn, it's really important to get that torque in there because that's really...
Crossbows are the strongest threads.
That's right. It's the best safety there is.
Can't move it forward, but can't move back.
Exactly. Can't move forward, can't move back.
Let's see. Some applications... Some applications call for wet torque. with a specific lubricant. With a specific lubricant.
Will they always supply the specific lubricant?
Will they supply it?
I mean,
Will they specify it?
specify.
Yes, they will. They will tell you exactly. This must be lubricated with food grade lubricant or STP mixture. Now I'm going to call out somebody, not in our class, who is somewhat famous for his advice. And he is correct. There are a lot of people out there who don't put engines together correctly. I would say more people put them together wrong than put them together right, even though this has not changed for a long time. And they do, so when you're doing cylinders, because I keep, pick on cylinders on aircraft engines don't oppose each other, they're offset. So the through bolts that are at the bottom of this cylinder happen to be the through bolts to the top of this cylinder. And there's some that go all the way through the case, some that don't go through the case. And when people take off a cylinder and put it back on, you're very myopic and you're working on this side of the engine. You take this cylinder off, you put this cylinder back on, and there are eight bolts, and you look at these, you go, okay, 8 bolts. Through bolt, stud, 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 stud. I lubricated them, I'm done. Well, guess what? You got to go around to the other side because those bolts came all the way through, and you have to torque those too. So when I did, especially Continentals, they asked, I did it at Buddy, Nathan. We did engines together. We would always call the other guy in, hey, I'm torquing a Continental, or even Lycoming, I guess we did all of them. Hey, torquing, final torque. And so he would have his calibrated torque wrench, I would have mine, and we would go opposites, click, click, next one, and opposites, click, click, and we would always torque them simultaneous. So we got a really good torque on it. What I was going to say is, so people are, they get the lube on, they're good. Well, there's some people out there who are purporting that, oh, I know that Continental asks for 100 weight oil, or I was going to look up exactly where it was. I forget exactly. I don't want to make you stand there while I was looking it up, but I'm pretty sure it's 15% STP. You guys know what STP is?
Drain cleaner.
No, it's boy. When I was a kid, it was all the rage. STP, the Racer's Edge. And it's hard to find, but it's an oil additive that looks a lot like honey. It doesn't smell or taste like it at all. It's this syrupy stuff that you would, oil additive, and it would then cling to the parts in the engine. So it makes the oil much stickier. And so when you put it on, it tends to stay. So, but this particular famous person is telling people on his radio call-in show, oh, you should use this, what is it? You know what I'm talking about. It's some product. No.
He swears by it.
Don't use what the manual tells you. You should use this stuff. It's even better. Well, what does better mean? It's more lubricant? The nut turns easier? Well, if the nut turns easier, you're increasing the torque. You're exceeding what the engineer did. So in my mind, correct me if I'm wrong here, or don't, the engineers figured this out. They're like, we need, let's just say, 11,000 inch-pounds of pull on this bolt, and if you use this specific mixture we came up with, and you turn it to this many inch-pounds, then that would equal exactly what we want. Do it dry, and you're going to miss by about 40%. Add something super slick and lubricant, you're going to pull it further than it should have been. You might as well just over-torque it at that point. You might as well just say, well, I'm going to use what the book calls for, and they want 600 inch-pounds, but you know what? If 600 is good, 800 is better. My torque wrench goes all the way up to 1,000.
Knows more than the engineer.
Yes. So I say that is wrong. Yes. If the book says they want me to use 100 weight and 15% STP and one booger from a dog, I don't know where that came from, I will pick my dog's nose and put a booger in it and stir it. Because that's what they want.
Then if something happens, you can say, I followed this and told me to pick my dog's booger.
But it would have to tell me how many grams the booger weighed.
Okay, there you go. But then the other one's like on a podcast, and it's like, oh, they told me on here.
Yeah, no, that's
That's not.
bad. If what you're using is more slick than what they told you, you're over-torquing it. And over-torquing it, I think it's probably as bad as under-torquing. I don't know. I'm not an engineer. Oh yeah, write this right here. Wet torque.
It's really confusing when you said you put a drop of Zeus booger.
I know. I have to. You have to.
What's that?
I'm going to write a manual that has that. And you have to come to me to get the Zeus burger. So wet torque. Let's see. Wet torque increases torque. Torque by about, because it depends on what you're going to use, 40%.
Wet torque is when you just apply lubricant to just the threads, right?
Yes.
Okay.
Now, when I say wet torque, they'll tell you. If the tool room guy wasn't coming out and yelling at me, you didn't put enough oil on it. So none of this little, hey, little drop right there and then a little drop on my nut and put it together. I use a bucket, a paint bucket with a quart, and I use a paintbrush and pull it on it, just get it all over the place. It's running on the floor and on my shoes. That's wet torque.
A little bit of oil is good.
Then a lot is better. And so one place where I can't see a problem with that. I can't see. Maybe it's an eye problem. Okay, so some are wet, some are dry. And some are just craziness. So, okay, I told you about that bolt in the back of the Lycoming where there's one bolt that holds the crank gear on. And there have been so many problems with that. Engineers, this is me speaking, they kind of looked at it and said, this is how it should go. And any mechanic in their right mind who's careful should be able to do this correctly. And then what happens? Mechanics in their right mind don't do it correctly. And so it becomes this big ordeal. It becomes an airworthiness directive and this giant service bulletin. And so now they would take the crank gear and then they had to cut scallops out of it. So it used to be this perfectly round base with the gear that was kind of in the middle. And then they had to cut scallops. So they had to take it and you had to buy a brand new one or take it to machine shop and cut all of this out right there. And then why? Because of mechanics. And so now it looked like this, because it only has one bolt in the center. Make it bolt red. One bolt in the center. And if that bolt fails, then the whole engine fails. So got this bolt right here. And so what it became is this procedure whereby, I say, one, you've got to run the bolt all the way in and then measure it to make sure that it is in fact going all the way in. Then you take it out. Then you put in the gear. And then you have to tap it with a brass hammer and you have to listen for it to go ping. Then you have to take a feeler gauge and you have to try to fit the feeler gauge underneath this gear. If you can, you've screwed up. Then when you get all of that done, you put the bolt in, you torque it to a certain amount, and then you do the whole thing again with the feeler gauge again, I believe. And then you do a final torque, and then you bend the tab over, and then now you're done. As we're back in the old days, make sure you put the gear on correctly, but it wasn't happening. Oh, and then the lubricant there is a food-grade lubricant. Now, if you've never seen food-grade lubricant, it's mayonnaise, right?
Seriously?
I didn't taste it, but it's it is mayonnaise, if you ask me.
Why did you have to get a machine?
It's food grade.
And cut that out?
Yeah.
So that you had room to try and put a feeler gauge in there to make sure that you got all the way down. So then there became ADs on these gears. So Lycoming then screwed up, or the manufacturer did, and they got bad bolts in there, and then you had to take the whole engine apart for bolts. So one gear is that's why Continental uses a whole bunch of them. All right.
Food grade means
Some applications are dry torque. Well, that was HIJKL. Some applications, most applications are dry torque. Honestly, most airframe stuff is dry, most engines are wet. I worked in an engine shop for a long time. I think one guy, it was before I went in there, I worked around it. And I'm like, when I got in there, I was like, I don't think the guy before me knew that most of that stuff was wet torque. Be surprised. All right, use of torque adapter. Use of torque adapter. Okay, so this is a torque adapter. And when you're working with torque wrenches, it's all designed, you can read this right here, it says length 10 inches, effective length 10 inches. Effective length 10 inches, it just keeps going. So its effective length is 10 inches from right between the knurling, so you're going to hold it like right there, right centered on there, to here, that to that is 10 inches. And so it's all calculated out. So if I'm pulling this at a certain thing, that's going to put a certain torque right there. But then if I extend it out, and I put a certain torque here, what's the bolt getting?
More.
It's getting more. So if I pull this to 100 inch-pounds, this is getting 110, 120, right? It's getting more. Well, maybe I don't do it that way. Maybe I do it this way.
Less.
Now it gets less. Or maybe I don't do it that way. I do it this way.
The same.
It's technically the same. Yeah, if you actually do it with a torque meter and you actually look at it, technically it's this distance and it changes a little bit, but just, for the most part, that's the same. And it's this short. So you have to figure that out. Now keep in mind that is different. I brought in a cylinder base wrench. That is the same because it goes right through the center, and this is in line with that perfectly. And they did that for a reason, so it'll be easy on you. I got to use this because that's a 3/4 inch drive. So what I was talking about is people go like this, and they grab this right here, and they're pulling on here, and this at the same time, or pushing up on this. They push on that, pull on this. That really changes your torque a lot. Sometimes you can go like, I don't know, I don't do it that way. I guess you could, this way.
They do feel a little funky to use it.
Yeah, you got it. That's why I tell people to go practice with this before you do an engine or cylinder. Go practice on the machine a couple times, 6 times, and take 2 people. You do it like, hey, I'm going for 300. Somebody's like, no, you're at 450. Well, how about now? Oh, there you go. You got it. And so, you practice. Sometimes you get cylinder base wrenches like this. It's kind of funky. It's kind of offset. I don't even know how to calculate that one because that's up here at an angle. That's why I brought it. So, all right. So if you're using a torque adapter, you must compensate for the extra length. So you must compensate for extra length. And 4313 has what you need. Right there. So it has a little torque wrench, and it has the adapter right there, and the formula is right there. So I'll go back. So formula is T times L divided by L plus E equals Y. I know, Y. Where T equals desired torque. Y is the unknown. Or what the dial should show. Yeah, what the wrench should show, dial or wrench. What I'm going to set the wrench to. L is length of torque, wrench. And E is length of adapter. All right, so let me see here. What do they do? They have 135 inch-pounds at 10 inches. 135 at 10 inches. They have 135. They have a 10 inch. So the desired torque is 135 inch-pounds, and the torque wrench is 10 inches. So what should Y equal in that case?
135.
Well, no, you want 135 on the bolt.
Oh.
So what should I set my torque wrench for? Or what am I looking at the torque wrench? So it's T, desired torque, 135, times the length is 10 inches, divided by the length of the torque, length of the torque wrench, 10, plus whatever the adapter is. Was that 2 in their example? I don't care. We're just going to go 2. So it's 135 times 10.
137.
That's not 137. Divided by 12 equals, now what is it?
137.
Thank you. 137 inch pounds. That doesn't sound right. Is it?
112.5. I don't know what it is.
Yeah.
Sorry. My bad.
You messed up.
Well, but take a look at that. He got 137. That's fine. But why did I suddenly know it's wrong?
Because you went over.
Because I'm torquing it more than it would be. And see, that's fine to make a mistake, but catch yourself. So we know it's not that. So how much is it?
112.5.
112.5. So if I put 112.5 on this, what is the bolt going to get?
135.
135. Bolt will be happy. Torque wrench is going, what are you doing? We're not done. You just shut up. All right. Now, if it goes the other way, it goes backwards, then it's the same thing. It's just minus 2. So it's 135 times 10 over 10 minus 2. So that's 130, divided by 8 equals
168.75.
168.75. Okay. Does that sound right?
Yeah.
Okay. So there we go. So torque wrench, you go, wait a minute, hey, we were supposed to be done at 135. Yeah, shut up, we got to keep going because it's not working. Now, what if you put it 90 degrees out? This is one of the 309 projects. Remember that? And everybody goes, I don't know what to do. Well, you can do it by math. 135 times 10 divided by 10 plus minus 0, because how many inches is it from here to here?
0.
Okay. What do you mean from here to here? Yeah, from here to here. From here to here. How many inches out was that? 0. So it's 135 times 10 divided by 10 equals 135. That's why mathematically that's 135. All right. Woo, man, bolting practices, bolting.
Man, we're chugging them.
I know. So the head of the bolt, or the bolt head, I could write bolt head, the bolt head should be installed facing up, forward, or outward. Is it? I didn't know that. So in other words, don't put the bolt in this way in an airplane, because if the nut falls off, so does that. Goes in forward, not backwards. Why? Because the air pressure holds it in, I guess. It goes from the outside in. Why? I don't know. It just, when you do it, it makes it like a little winglet. That's how I remember. So if you had 2 bolts. So. To me, this way and this way is practically the same, but do it outward. So that way if the nut falls off, which hopefully it doesn't, then the bolt stays put. I did have a customer one time. I tell the same stories. I don't know if I tell the same stories or not, so I hate it. Where that procedure saved his life. So it was the first time I did an annual on this guy's plane, the little Cessna 150. And so I was doing the annual on it, and you use your ears a lot. And so I was moving the elevator, the ailerons, and every time I get to the very top, I go click, clunk, click, clunk. Well, it's not supposed to make that sound. So I kept doing it and kept looking, flashlight, kept doing it, follow the noise, follow the noise. Well, the cables, they come from the yoke and down around the floor and up and over and all the way down. They go out to a bell crank. So they push and pull out there on the bell crank, and there's this thing that moves back and forth. And on that is a rod that goes out to the aileron. Well, this was down in one of the rods that was going to the aileron. And every time I did it, the little click clunk was a thread coming out. Thread, a thread, a thread. And I caught it just as it was ready to fall out. There's no nut on it. Yeah. That wasn't the weird part of the story. The weird part of the story was... Huh? No, the really weird part of the story was we'd never had this guy as a customer, and he's probably not going to watch YouTube. And I don't know what happened in the office, what they told him his bill was going to be, but I mean his plane was jacked up, and I saved his life. And he came in to pay the bill, and I remember there was some words being had, and the boss called me in and asked me to sit down and kind of explain what I did. So this is kind of the boss's fault. He didn't prep the guy, so they kind of surprised him with an annual. They should never have done that, but so I just went down the list. I had to do this, I had to do this, I had to do that. And so the guy wrote his check, and he wrote on the memo, paid under protest. And then he storms out, and this is out in Clarksburg where there's no control field and it's a grass runway, and the runway is this way, and his plane was like in front of the hangar. And he gets in, no pre-flight, no nothing. He's just pissed off. It wasn't you, was it?
No.
Okay. Gets in the plane, slams the door, starts it up, and firewalls it right there. Almost ground loops it making the corner and flew off. I mean, just, all right. Never heard from him again.
That guy's so cool.
He showed me. Well, I remember it after all these years, so I guess he showed me.
He not only paid in protest, he flew away in protest.
Yes, he did. But you know what? He paid. What's that? Yeah, I know.
Yeah.
That would have really showed me. I'm going to crash my plane. That way the FAA is going to really investigate you. He didn't care about that.
That's hilarious.
I think his point was it hadn't fallen out yet.
And that's what they haven't got the expression. Just go away, angry.
Don't go away, man. Just go away. BFO, or before, get to thinking about other things. The greatest point of failure on a bolt is the last thread before the shank. Before the shank. So do not line up parting surfaces on this point. So in other words, you have two pieces you bolted together, and the bolt's going through. I'm glad I have a bolt here. Make sure you get a bigger one. Don't make the two parting surfaces line up right there on that last thread, because if they're kind of wanting to do this, that's really, it wants to fail there anyway. So don't do that. Let me see.
What do you mean fail? Do you mean like break?
Yep. Applied torque is I kind of talked about this a lot, is an estimate on how much tension the bolt has. So remember, you twisting it, nobody cares about the twist. You care about the pull. But you can't measure the pull, you can only measure the twist. So the twist is just an estimate on how much pull there is. So it's an imperfect system. Let's see. The ultimate goal is tension, not torque. The ultimate goal is tension, not torque. So you're torquing it to get the right tension.
When you over torque, it's threads failing before the bolt, usually, right?
Usually. Boy, this is a lot to write. Think of a bolt as a spring that is clamping apart. As long as the load on the spring does not exceed the spring tension, the spring does not move. If the spring moves, it is subject to work hardening and failure. I'm not going to write that.
Spring. Threads, spring.
How much time do I have? All right. We'll put use of lube. I already said a lot of this stuff. So lubricants, lubes can change torque. torque by 50%. I know at one point I said 40%, but it's a different way of saying it. 40 to 50%. Let me see. Using lube where not allowed adds too much tension. Oops, I actually wrote that. Can cause too much tension. Too much tension and result in a broken or stripped bolt. Not using tension, or no, I'm sorry, not using lube can cause loss of preload. You know what I mean by preload? Because I talked about that. And that was my cylinder example, where the cylinder is trying to depart the crankcase, but you actually preload that bolt to so much tension that it's already exceeding any tension that the cylinder has of wanting to go that way. So the tension in that bolt is, even when the engine's sitting there cold, is greater than that cylinder wanting to leave during full horsepower. So that's what I mean by preload. You've stretched that bolt. It's really tight, and it's like, just hanging on there. And it's just sitting there. So not using lube can cause loss of preload. And so the cylinder, every time it fires, the cylinder wants to leave, and it stretches the bolt just a little bit, stretches it, because the preload isn't enough. The cylinder wins, so it stretches a little bit, stretches a little bit, stretches a little bit, snap, and it does that 6 or 8 times, and then the cylinder lays down. That's what the cowling is there for. It lays in the bottom of the cowling. Some people put a little rope or string around their cylinders so that it doesn't fall all the way out and mess up your weight and balance, and you can put it back on when you get to where you're going. That's only partially true. Loss of preload and result in a broken bolt. If lube is required, lube nut and bolt. Don't just do one, do them both, do a lot. One of the things, and you guys, it's been a long time for you. So engines, they go together, they're aluminum case halves. And you put the crankcase, you put the crankshaft and the camshaft, all this stuff in. You take the other one, they got the bearings, and they go together. And where they come together, the cases come at one point and they're mashed together, and then the through bolt goes right through that. And they have to be tight. And when they're not, you lose that preload. Not only are you going to risk losing studs and the cylinders start working, but then everything right there starts to work. And so that case starts to fret, goes back and forth and frets. And that causes aluminum then to go, you'll see higher aluminum content in your oil analysis if you do it. But you start losing bearing material. And pretty soon your case is kind of loose right there. And what happens is, inevitably, somebody may take a cylinder off or figure it out. And, cylinder goes bad, you take the cylinder off. Then at that point, you get a good mechanic, or you do it, and you know better, and like, oh, Kevin said we should use lubricant. And so you do it right, and you put that on. Oh, I'm supposed to take the other side off. And the through bolts, and I'm going to lubricate them, and I torque it properly, and that little space that shouldn't be there pulls together. The bearing halves tighten up more than they should have, clamps down on the crankshaft, and then you start to run it, it seizes up.
Dynamic disassembly.
Yes. And even if it doesn't, like I did so many Lycoming, I do like Lycoming, and I like Continental too. But man, it seems like even the factory engines, especially out of Lycoming, maybe because they use impact wrenches, I take a factory engine apart and there's crankcase fretting. And so I would say 75, 80% or more of the engines that I did all had to go out to have that fretting repaired. And what they do is they take it and I send it out to a repair station that was certified for that. And they mill it flat on both sides, put it together, they have to weld all the holes, then re-drill it, and it actually brings it in a little tiny bit. And if my mind, if you bring in a little tiny bit, that means the piston's going to get a little bit higher compression, so it's a better engine. But
More power.
more power. But yeah, that's, if nothing else, it's a $2,000 repair. It's every single time. There was a really old, I wish I could find it. There was a Lycoming service instruction. It's gone now. But they actually, at one point, and I don't know why it went away, but there was a procedure whereby before you took a cylinder off, they wanted you to take sandbags and take all the spark plugs out and put sandbags on the propeller and figure out how much weight it took to move the propeller through a certain arc. Then you would do all of your work, and then when you were done, you had to do that, and it couldn't change by more than X amount because they figured what you were doing is crushing the bearings around the crankshaft, and we're going to have an imminent failure. But that went away.
Come up with some pretty clever ideas.
I know. Paint under a bolt or nut. Paint under a bolt or nut can cause loss of preload.
Is that also why you would put a washer?
No, but like going back again to cylinders, because it's what I know, I guess. If you paint your cylinder base and then you put a nut on that, you've put some paint there, and there's a little bit of wear that's going to happen. That paint goes away, and then you got a little bit of space. And so the only thing you're allowed to have is like a thin coat of zinc chromate or primer on it, very light. You can almost see through it. And I think my last point here, if not improper, improper gaskets can do the same thing.
Like too thin, too big?
Improper, gaskets or sealant can cause loss of preload. So I worked with one guy, not around anymore, and that was his thing. He's really prided himself. My engines don't ever leak. And so when you put a cylinder on an engine, it takes a little O-ring. Remember? Okay, it's metal to metal contact, but there's a little chamfer in there where they actually cut out a piece of the crank case where an O-ring will go, and the O-ring fits in there, and this is a little O-ring. But it's made. There's a little cutout for this O-ring to go in there. But this guy would always, he called it Ockampucky, as tight seal. It's just this gasket material. And he'd always put that seal on, put a bead all the way around, a nice thick bead. And you put the cylinder on, start to torque it, it would squish out, and you just wipe it off. Well, what do you think happens when that stuff wears out? Now, Lycoming and Continental talk about this all the time because people still in the field still do it. They take RTV, gasket maker, put a little bead in there, my engine's not going to leak. No, it's not going to leak for a while, but the studs are going to start falling off, and that's really going to make a problem. It's going to leak when the crankcase comes apart. So you can't put anything, if it doesn't call for it, don't do it. Now, people try and engineer things when they shouldn't be engineering things. All right. They're trying to do the right thing. That goes back to, remember the Dirty Dozen thing? Where the guy had the DC-10 engine fell off and they killed everybody, and then the mechanic killed himself. They're just, the reason why they were doing it wasn't because they were lazy or stupid. They thought they were saving the company money and doing the right thing. So just have to be careful. And that's why those are there. When I got into the engine shop and I kind of took over, I changed everything. And the boss was like, why did you change? Why are you doing it that way? Who told you to do it that way? I'm like, well, it's just simple. It's right here on this page. Why come we didn't do it like that before? I don't know. Then you get all mad. We should have been doing that for years. Well, you didn't ask me. Yeah.
Well, and I think McDonnell Douglas specifically stated whenever American Airlines or whoever submitted the application to do it the way that they were doing it, they said, well, we can't tell you not to do it that way. We just don't recommend you do it that way.
Interesting that they would say it that way. We can't tell you not to.
It's like we can't, because it's technically their aircraft.
Oh, yeah. And their procedures, and they get to write manuals and all that kind of stuff. But They were using a leaky fork truck that the forks dropped down and all broke, and I went over that. So, all right. So let's see. Not test tomorrow.
Nope.
No.
NDT.
NDT. Well, I guess we could come in here and cover NDT. That's probably the most smartest thing. Or do extra lab. Huh?
Across the street.
Tomorrow? Not now. It's time to go.
Well, yeah, not now.
If you want to, we can go over there for 1 minute. All right. That's all I got.